Hello students, today's topic is variance. Variance of x equals to sigma square. In the next step, we can write it as in this way. Next step, Ex can be written as mu Now we will use the identity a minus b whole square. So it will become x square plus mu square minus 2 mu x. Next step, okay, then we will write this will remain same plus expected value of a constant is the number itself. So expected value of mu square will be mu square minus 2 mu and expected value of x is mu. Okay, and this will become right. In the next step, we will write this can be written as in this way, right? So this is the final formula of variance of x, that is ex square minus ex whole square. Okay, this one, fine. Next we have property of variance, which is variance of ax plus b equals to a square times variance of x. Let's see its proof. Let z equals to ax plus b. Now we will take expected value of z and it will be a expected value of x plus expected value of a constant is the number itself, so expected value of b will be written as b, right? Now z minus ez will be a x minus expected value of x. Okay, next squaring both sides. So this will become z minus ez whole square, and this will be a square x minus ex whole square. Now we will take the expected values. Okay. Now observe this term. This can be written as variance of z equals to a square, and this one can be written as variance of x. Now we will replace z by ax plus b, which is a square times variance of x. Okay. Remarks. First one is variance of a constant is 0, and the second one is that expected value of x square is greater than or equal to expected value of x whole square. Proof of this second remark can be done as follows. We know that variance of x is greater than and equal to 0. So in the next step we can write it as expected value of x square minus expected value of x whole square is greater than and equal to 0, right? We can write variance as in this form. In the next step, expected value of x square is greater than and equal to expected value of x whole square. Fine. Now let's solve this question. Let the random variable x have the distribution as given in this form. For what value of p is the variance of x a maximum? So here we have given this distribution. Let's first calculate expected value of x. So it can be calculated as 0 times probability that x equals to 0 plus when x is 1, probability that x equals to 1 is 1 minus 2p. So we will write 1 minus 2p plus, and when x equals to 2, then its probability is p. Okay, this will become 0 plus 1 minus 2p plus 2p. Okay, this will be cancelled out and expected value of x is 1. Now let's calculate expected value of x square. This will be so 0 square times p plus 1 square times 1 minus 2p plus 2 square times p. 0 plus 1 minus 2p plus 4p, and this will become 1 minus, sorry, it will be 1 plus 2p. Okay, so we have calculated Ex and Ex square. Now variance of x, which is expected value of x square minus Ex whole square. So Ex square was 1 plus 2p. We will write 1 plus 2p minus Ex. Ex is 1. So 1 whole square. In the next step, 1 plus 2p minus 1, 2p. So this is the variance of x. Okay, and the range for p in the question is given as in this form. Zero less than and equal to p less than and equal to half. So we can write, therefore variance of x will be maximum when p achieves its maximum value, which can be half. So when p equals to half. Okay, variance of x will be maximum when p achieves its maximum value, which can be half. Next question. Let x be a random variable which takes values 1, 2, 3 till n, having probability mass function as this. Find Ex and Vx. So here we have given this probability mass function, and we need to calculate the expected value of x and variance of x. So let's first calculate expected value of x. Because this is a discrete distribution, so expected value of x will be this one. In the next step, x equals to 1 till n, x times fx, which is 1 by n. So times 1 by n. Next step, 1 by n sigma x equals to 1 till n x. It can be written as 1 upon n, and this will be 1 plus 2 plus 3 plus till n. Okay, 1 upon n, and this will become n plus 1 upon 2, because the sum of first n natural numbers is this one, n plus 1 upon 2. This will be cancelled out. This is n plus 1 upon 2. So expected value of x is calculated as n plus 1 upon 2, and now we need to calculate variance of x. So first we will calculate expected value of x square. Next step, fx is 1 upon n, and this will become 1 square plus 2 square plus 3 square and till n square. This will become n plus 1, 2n plus 1 upon 6. This will be cancelled out and it will be n plus 1, 2n plus 1 upon 6. Okay. Now variance of x, which is ex square minus expected value of x whole square. Ex square is n plus 1, 2n plus 1 upon 6. So we will write n plus 1, 2n plus 1 upon 6 minus ex. Ex was n plus 1 upon 2. So n plus 1 upon 2 whole square. Next step, n plus 1, 2n plus 1 upon 6 minus n plus 1 whole square upon 4. Next step, we can take n plus 1 common. Terms left in the bracket will be 2n plus 1 upon 6 minus n plus 1 upon 4. Okay. Next step, n plus 1, and in the bracket we can take LCM as 12. So this will become 2 times 2n plus 1 minus 3 times n plus 1. Then n plus 1 times this will become 4n plus 2 minus 3n minus 3 upon 12, which is n plus 1 times n minus 1 upon 12. So we can use the identity a plus b, a minus b, and it will become a square minus b square, that is n square minus 1 upon 12. This is variance of x. Okay. N square minus 1 upon 12. Next question. Ex equals to 5 and this one is 27.5. We need to find expected value of x square and variance of x. So we have given this information and we need to find ex square, right? This is equal to 27.5. Okay, so this is 27.5. Next step, this will become x square minus x, 27.5. Next step, okay. Expected value of x is given as 5, so we will write 5. And last step, ax square equal to 27.5 plus 5, which is 32.5. Okay. Now we need to calculate variance of x. So we know that variance of x is equal to ex square minus ex whole square. This is 32.5 and expected value of x was 5. Okay, and this will become 7.5. Fine. So variance of x is 7.5. Done. Next question is, if a less than and equal to x less than and equal to b, then show that a less than and equal to expected value of x less than and equal to b. So we have given a less than and equal to x less than and equal to b. In the next step we will write okay. Next step, this will become 1, as we know that the sum of all the probabilities is equal to 1. So sigma fx is 1, less than and equal to, this is the formula of expected value of x, and again this is equal to 1. Okay, so we can write hence proved. Thank you.